Okay, I'm just going to go through the first questions quickly because we did these in class. So look at this bit. This is the universal set. This tells you what everything that's in the whole box is. So it's the positive integers less than 10. That doesn't include 10. So we're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you have to decide where each of these numbers go. Well, A is 2, 4, 6, 8. B is those numbers. Is 1 in either A or B? No, so 1 goes outside. 2 is in A but not B, so it goes here. 3 is in neither, it goes outside. 4 is in both, so it goes in the middle. 5 is in just B. 6 is in both, so it goes in the middle. 7 is in just B. 8 is in both. 8 is in just A. And 9 is in just B. And then we've covered all the options. So there's 4 categories, remember, whenever you have, so if you have 2 different groups, then there are 4 categories. That it can either be in neither, both, or just A, or just B. And those are all exclusive categories, i.e. Yeah, there's no overlap between them. If you're asked to list the members of A in section B, which this person has done, don't forget the curly brackets. And obviously it's better to list them in ascending order, but that doesn't matter terribly. Also, they haven't got it right. Oops. A into section B. The whole Luka Modric, Arnold Schwarzenegger thing is to try and get you to stick with the concept that intersection is the restrictive one. When you see the intersection, you know that it has to comply with all the rules to be in the intersection. So it has to comply with this rule, and it has to comply with this rule. Now, if we look at the 2 rules, A means 2, 4, 6, 8, B means 4, 5, 6, 7, 9. Which numbers comply with both the rules? Well, 4 and 6 do. So the way we've drawn it, 4 and 6 are the only things which comply with both rules. And then, if we're looking at union, remember that union is like, it doesn't matter if you're in at least one of the rules you're in. So if you're in A, that's cool, you're in. If you're in B, you're in. It doesn't matter whether you're in just one of them or both. So you're looking at everything which is in either of these circles. So 2, 8, 4, 6, 5, 7, 9, all of them are in at least one of the groups. Now, I say circles, slightly misleading because obviously when you get into complement it gets more confusing. So just remember for union, everything that fits rule A is in, so 2, 4, 6, 8 are in. And then everything that's in B is in as well. So 4, 5, 6, 7, 9 are in. If you started dealing with complement, then remember that A complement is all the objects which are not in A. So if the universal set is all the numbers 1 to 9, and A is 2, 4, 6, 8, A complement is everything left over. So 1, 3, 5, 7, 9 in this case. And if B is 4, 5, 6, 7, 9, and the universal set of these numbers, then B complement is everything that got left out of B. So 1, 2, 3, 4, 5, 6, 7, 8. And obviously you can put the commas in here. But just remember the complement is within the universal set, within the set of numbers or the set of objects that we're dealing with, the complement is everything that's not in that group. So if we were looking at something like A intersection B complement, it would be everything apart from, that's A intersection B by the way, everything apart from 4 and 6. A union B, which should be this one, would be everything apart from those numbers. Hopefully that's not too confusing. If you turn the page, it does ask for A complement. Wait. It does ask for A complement, which is what we said it was. And A union B complement is everything apart from the numbers in A union B, which is 1 and 3. The number of elements, we talked about this, so it's just the number of things that are in each category. The number of elements in A in section B, in this case, is 2, and the number of elements in the empty set is 0. The converse of that would be the number of elements in the universal set. How many objects are there that we're dealing with? We define the universal set as the numbers 1 to 9, so there would be 9 values in that. Okay, question 2. I'll just run into that, seeing as we did that all in one go. Remember, cumulative frequency is the running total of the frequencies. So if the frequencies are going 9, 15, 19, etc., the first cumulative frequency from 0 to 10 is going to be 9. The next cumulative frequency, now, technically speaking, this table is wrong. Cumulative frequency, this should say 0 to 20, because the cumulative frequency is everything in 0 to 10 and 10 to 20. So you just add these two. So the first one is 9, the second one is 9 and 15. The next one is going to be 9, 15, and 19. So it's like a running total. You add that on. You add 17 onto 43 to get this one. You add 13 onto this to get this one, and so on. But these should actually say 0 to 20, 0 to 30, 0 to 40, 0 to 50, and 0 to 60. This cumulative frequency row is wrong. Because the cumulative frequency tells you how many people have got up to the top value. 9 people got up to 10, 24 people got up to 20. Why does that make sense? Well, if 9 people got between 0 and 10, and 15 people got between 10 and 20, then 24 people must have got between 0 and 20. You're combining those two groups. And 43 people, sorry, must have got between 0 to 30, because that's what the first 3 groups make. I hope that makes some sense. When you plot, remember you plot cumulative frequency on the y-axis and the end of each category on the x-axis. So this will be 10 on the x-axis, 9 on the y, 20, 24, 30, 43, 40, 60, and so on. You get usually a sort of S shape, like this. And then be careful about where the top value is. The top value is where the curve ends. So in this case it's 80. You do half of that, that will be your median, which is 40 in this case. So you go across and down, and this will be the median value. A quarter of 80, which is 20, will give you a lower quartile, wherever this hits the ground. And 3/4 of 80, it's not always 80, by the way, but just 80 seems to come up a lot. 80 is the total in this case, so that will be the upper quartile here. And so we've got some values here that work out pretty well. The last question is about finding the fraction of plants which are above 45 centimeters tall. Ignore this for a second. 45 centimeters, so we go back to our data and we look where 45 is, and we go up and across as this person has done, and we get a cumulative frequency of 66. Now going from 45 centimeters and getting a cumulative frequency of 66 means there are 66 people got up to 45 centimeters. The question asks what fraction got over 45 centimeters. So if you have 80 people in total and 66 people got up to 45, the remaining number, 80 minus 66, which is 14, got over that. So 14 people are left. These people up here got more than 60 centimeters. So as a fraction of the whole, it's 14 out of 80. But usually it doesn't ask for a fraction, it just asks for the number. Anyway, that's questions 1 and 2.